Hello my dear students, this is Akash HD. Welcome to the AHD physics classes. Hope you all are doing very good. So students, in this video we are going to solve the question from the chapter Rotational Motion 11th asked in a JEE 2025 exam. Okay, let's go through the question. Question is somewhat confusing and conceptual also. Now let's go through the question. So the question is, what can you see here? The moment of inertia of a solid disk rotating along its diameter is 2.5 times higher than the moment of inertia of a ring rotating in similar way. Okay, this is one thing they told. After that, see, the moment of inertia of a solid sphere which has same radius as the disk and rotating in similar way is n times higher than the moment of inertia of the given ring. Here n equal to how much, and they are telling consider all the bodies have equal masses. So when you will read the question multiple times, you have to read multiple times, somewhat confusing question. So here you can see what are the things they are talking about. First they are talking about the solid disk, is it? Then they are talking about the ring, okay, and then they are talking about the solid sphere here, is it? So I will take one by one. This ring I will take body 1, okay, and this solid disk I will take body 2, and this solid sphere I will take body 3. Again I am telling, ring body 1, solid disk body 2, and solid sphere what is there, body 3, is it? So now one by one. Here one more thing is there, students. What they are telling, that here they are telling rotating along its diameter. What they are telling, rotating along its diameter. Okay, so see here, if I talk about here, this is ring. What is this? This is the ring. So in this ring, let's take this is having radius r1. Okay, so remember that here you know the formula. When axis is passing through the center of mass of the ring and perpendicular to the plane of the ring. Okay, so you can see this ring in which plane? This ring in zx plane, and axis, this perpendicular axis is y. So if this ring is rotating about y axis, its moment of inertia is used to be mr square. Now for the ring I am telling, but here they are not telling this axis, they are telling about the diameter. Now so diameter are the which axis? Diameter are the maybe x axis or maybe they are the z axis. So here remember that here when I will apply the perpendicular axis theorem, that we will get the moment of inertia about x axis or the z axis, is it? So about x axis, moment of inertia I1, both have diameter, and even about z axis also how much here, that is also I1 here, because x is also diameter, z is also diameter here, is it? And y is perpendicular to the plane of the ring, is it? So if I talk about here the perpendicular axis theorem, it tells that, now very simply I am using here, Iy is equal to Ix plus Iz. Okay, so what is Iy? I is the mr square and mr1 square. Here I am taking radius how much here, r1, and Ix is I1 and this is also I1. So mr1 square equal to 2I1. So from here if I write here what is I1, students, so I1 will be mr1 square by 2. Even if you remember this formula directly also, very nice about the diameter. Otherwise I have told you the basics. I1 how much here, mr1 square by 2, is it? This is for the ring. Now this is for what? This is for the ring, first body. Next one after that, if I talk about here for the disk, for the disk, see the second body what I have taken here, the second body is the disk. For disk you know very well, if in case this is the disk will look like this. Now this is there, now it will be solid like this here, solid. Now this is ring, this is disk. So for disk what will happen, if in case this disk in a zx plane and this is y axis, no? Same axis I am following here, is it? So what will happen that here, if I talk about here this ICM, so this ICM for the disk will be how much here, mr square by 2, is it? But in the question they did not talk about the radius of solid disk and ring, and their moment of inertia is not same. They are telling some 2.5 times and also definitely what is there, the radius is different. So what I am telling you here, let's take here this disk is having radius r2. Okay, so here what will happen that here, if I talk about for the disk, here also what I can tell here, see, Iy equal to Ix plus Iz, is it? And this is the center of mass, moment of inertia used to be how much here, mr square by 2, but radius how much here, r2. So I have taken here mr2. So what can I write here, see, mass is same only, mr2 square by 2 is equal to, now I am taking here their moment of inertia is how much here, about this axis. Now see this is the x-axis. This is the z-axis. Both are the diameters. Both are the diameters. Okay. So let's take about x-axis also I2. About the z-axis also how much here? I2. Is it? So what can I write here? I2 plus I2. Is it? So hence if I will solve this, this I2 will come here mr2 square by 4 about the diameter. Is it? This thing is clear. Next one, students, after that if I talk about for the solid sphere. Solid sphere, this is body third. No? This is the solid sphere. Solid sphere is the three-dimensional body, not a problem. So let's take here. The axis is again passing through the diameter. Here directly you can use the formula. Let's take here, this is I3. But in the question they told, you can see very well here, solid sphere has same radius as the disc. Now disc radius, what I have taken here? Students, can you see here? The disc here, see here, students. Now, so ring radius I have taken R1, disc radius I have taken R2. Is it? So in the question what they are telling that here, again I am telling the moment of inertia of a solid sphere which has same radius as the disc. Okay, so disc radius I have taken R2 here. So here also what will happen that here, this radius is also R2 I will take here. Is it? So when I will take this radius R2, remember that here I can write here this I3 equal to 2 by 5 m R2 square. Is it? Because what is there? The radius of the solid sphere and the radius of the disc in the question they are telling same. Is it? Can you see very well? So this is for the solid sphere here. Okay, and this is I2 is for the which one? For the disc. Okay, students. So this individually we have calculated now. Now we will negate the questions here, please. The moment of inertia of a solid disc is 2.5 times higher than the moment of inertia of ring. Is it? So what can I write here? Can you see here? According to the question, students, according to the question, this I2, now that means disc is what is there? 2.5 times of the moment of inertia of the ring. Axis is same only. Is it? So what is the I2? This is disc. Again I am telling that here. This is disc. Okay. And this is what? This is the ring. Now, so I2 disc, what we have got here, students, can you see here? The disc was 1 by 4 mr2 square is equal to what they are telling that here? 2.5 mr1 square. Is it? Can you see here? Very well, according to the question. So m and m, this will be cancelled. That means we can write here, kindly see very well, no? 2.5 times, no? And here by 2 also there, correct now? mr1 square by 2, correct here? See the students, what is coming here? See, mr1 square by 2, is it? So see here, mr1 square by 2. That means what will happen that here, students? If I will just write here, see, r2 square by 4 is equal to 2.5 by 2 and here r1 square. Okay. Now when I will simplify this here, just see here, if I write here r2 by r1 square is equal to how much it will come here, students? This 4 by 2 into 2.5. 2 2 is 4 and 2 into 2.5 means 5. Now, so this is, we have got here the first equation. What is coming now? See here, r2 by r1 whole square is coming 5. We are comparing for the disc and the ring. Okay. After that, in the question, what they are telling, see again, this color. The moment of inertia of solid sphere which has same radius as the disc and rotating in similar way is n times higher than the moment of inertia of the given ring. Okay, can you see the question here? Radius of the disc and the sphere is same, but this is n times higher than the moment of inertia of the given ring here. Okay, so ring what I have taken here, students? Ring I have taken I1 and solid sphere I have taken how much here? I3. So according to the question, again what they are telling here, can you see here? They are telling I3 is equal to NI1. Now this is for the solid sphere and n times of the ring. Now can you see here? This is the situation. This is the situation. So see here, I3 solid sphere, what will come here? This solid sphere is having the same radius. The solid sphere is having the same radius as of the disc. So disc radius I have taken R2. Solid sphere also I have taken how much radius? R2. So what is coming? 2 by 5 m R2 square here. Now let me write here. This is coming here. See, 2 by 5 m R2 square is equal to n times ring. Ring what is the? Already we have seen. See, I1 ring will be how much here? mr1 square by 2. Is it? So kindly see, mr1 square by 2. Now question is somewhat confusing. but if you will read the multiple times and you will try to solve, it will be very easy. This mm cancel, is it? So students, from here, if I will simplify this here, no, this question. So whatever the things are left here, you can see very well. 2 by 5 r2 square is n times of r1 square by 2. Is it? So if I will get the value of the n, what will be n? N we can write here 2 into 2, 4 by 5 into r2 by r1 square here. Is it? So 4 by 5. Now, and what is r2 by r1 square value? See here, r2 by r1 square value is 5. That means into 5. Hence, the value of n is coming how much here? 5, 5 cancel. The value of n is coming here 4. Is it? So, this is the situation here. Okay. So, students, what is the value of the n? The value of n is coming here, students. The value of n will be here 4 here. The value of n will be 4. Is it, students? So, I hope so. This question is very, very clear to you, in which what is there? Again, I am telling the radius of the disk and the solid sphere is same, but the moment of inertia of solid sphere is n times the moment of inertia of the ring. Now, just go through the question. It is very easy, very, very clear. So, students, keep studying, keep growing.